Hello friends, how are you? OSHA. On December 29, 1970, President Nixon signed the Occupational Safety and Health Act of 1970, OSH Act, into law, establishing OSHA. Coupled with the efforts of employers, workers, and safety and health professionals, unions, and advocates, OSHA and its state partners have dramatically improved workplace safety, reducing work related fatalities by almost 63%. This plan shows OSHA approved state plans. In the sky blue color, it shows OSHA approved state plans, that is, private sector and public employees. In the dark blue color, states shows federal OSHA, that is, private sector and most federal employees. And in the sky blue color with strips, OSHA approved state plans for public employees only. Private sector employees are covered by federal OSHA. In the previous video, we have seen important definitions in the OSHA. In this video, we will see all the standards required for steel erection. So, let's watch today's video. OSHA safety regulations for steel erection. From the manual detailing for steel construction by AISC and NISD from the chapter 2, page number 2-12 to 2-17. Today's topics: scope, tripping hazards, roof and floor holes and openings, column anchor rods, minimum erection bolts, double connections, column splice strength, column splice locations, perimeter safety cable attachments, joist stabilizer plates at column and joist. The shop placement of shear connectors, weldable reinforcing bars, deformed anchors or threaded studs is prohibited when they obstruct the walking surfaces of beams or joists, as shown in the figure. The shop placement of threaded studs on column cap plates to receive stud joist, deformed bars on column waves, or even shear studs or on beam or column waves is not prohibited, since these are not walking or working surfaces. Where design constraints and constructability allow, the structural supports for deck openings are to be fabricated so that decking runs continuously over the opening, as shown in the figure. This does not apply to major openings such as elevator shafts or stairwells. Other deck openings are not to be cut until the opening is needed. Column should have minimum 4 or more anchor bolts, and these anchor rods and column foundation should be capable of supporting 300 lb of load at column top located at both 18 inches from face of the column flange from a plane at the tips of the column flange, except for post. Posts are not required to have 4 anchor rods. The structural engineer of record must design a column base plate and supporting foundation to accept the 4 anchor rods. The clear distance between the column flanges, like this shown in the figure, may not allow for a significant spread between the anchor rods when placed inside the flanges of W8 and W10 columns. As for W8 it is only 7-1 by 8 inch, and for W10 it is 8-7 by 8 inch. So it is recommended that they should be placed outside the column base at the base plate corners. The designer may give consideration to the fact that base plates frequently require slotting in the field to accommodate misplaced anchor rods. In the erection of all columns, the erector must evaluate the job site erection conditions and factors such as wind, when the columns will be tied in, etc., and determine the necessity for guying or bracing. Minimum erection bolts. The requirements given in the regulations are the minimum number of bolts to be used during erection to support a member until the crane's load line is released. Two bolts in each connection are the minimum to connect solid wave members, and one bolt is the minimum for solid wave bracing members, or the equivalent as specified by the project structural engineer of record. The initial minimum bolts are to be the same size and strength as shown in the erection drawings. The erector is required to maintain the structural stability at all times during the construction process, and the determination of the number of bolts required to temporarily support members is a responsibility of the erector. Double connections. Only double connections of beams to column waves or to the waves of the girders over columns in the case of cantilevered construction are regulated. Not such connections at locations away from the columns. These boxes, the bay with strut beams. The rule is based on the fact that an erector commonly sits on the beam on the first side of the double connection, while the beam on the other side is connected in these regulated instances. If the connection gets away from the erector, beam and column collapse can occur and erector may fall. Typical beam-to-beam double connections, other than at a cantilever over a column, require no special consideration, since the erector can instead sit on the girder that receives both beams. These are some images for beam erection. At column conditions, there are many ways to facilitate safe double connections. The staggering of end angles on each side of the column wave, single staggered, as shown in figure 2.13, may not stabilize the beam's top flange unless metal deck is present, and the angles may be better staggered on each side of the beam wave, that is double staggered, as shown in figure 2.14. So in this figure 2.13, this is the column wave, this is the beam. This beam is erected first and this beam is erected second, and these are the staggered double connection on each side of the column wave. So this is single stagger. In the figure 2.14, this is the angle on the far side of the column wave held down one hole or clip, and this is the angle on near side of the column wave held down one hole or clip. This is the double connection staggered on each side of the each beam wave. When seats are used, the beam must have a positive connection to the seat, while the second member is erected. The figure in the OSHA Standards Appendix H shows clip plates where the end plates are used as shear connections. So in this connection, this is double connection with the temporary bolted erection seat. So this is the seat angle used with 3 by 8 inch minimum clearance for the beam erected first. These are double connection on each side of the column wave, and this is the beam erected second. This is the double connection with shop welded erection seat. So this seat angle is shop welded and field bolted to this beam erected first with a clearance of 3 by 8 inch minimum. And here this is the double connection with shop welded erection seat. This is the alternative location of the seat angle. Summary: we have seen tripping hazards, roof and floor holes and openings, column anchor rods, minimum erection bolts, double connection. For the content in the video, all credits are given to the AISC committee who prepared the manual detailing for steel construction. I am grateful to them. Thank you so much. Thank you so much to you all for being with me throughout this video. I am grateful for your support. We will meet in the next video. Bye bye. If you find this video useful, then please share. It will help others. And subscribe to get notified about the new videos. For more information, you can visit to www.osha.gov